Welcome, everyone. We're really excited to have everybody here today. Today, we're going to talk about manufacturing engineering at Michigan Tech, and especially our online programs. So we brought a really robust panel here today. We're going to talk a little bit about, here's our agenda. We're going to do some introductions, talk about online manufacturing engineering at NYMTU, program pathways, next steps, and questions throughout this. But a couple of housekeeping things as we go forward. I do want to guide you to the chat function. We're going to ask you to ask questions in the chat function. And then periodically throughout the presentation, we'll do our best to get those questions answered, because that's kind of what today's really about. It's about getting your questions answered and helping you move forward in this process. So please ask your questions in chat, and we'll do our very best. We're also going to drop in some links into the chat that will probably give you even some more robust, deeper information on some of the information that we're going to pass on today. So some of you may also be part of our, one of our corporate partner programs. Today's presentation is about the actual academics and getting into the program. It's not the nuances of our corporate partnership. So if you do have those questions, we'll guide you kind of outside of this particular presentation if you're coming here from a corporate partner thing. But we're going to kind of pass on through this. So we're going to move on into the next slide and do some introductions. So I'm Jacques. I'm the Director of Graduate Enrollment Services. I work in the graduate school, so I work very closely with Global Campus and our academic partners here to help students get into our programs, help kind of solve all their admission questions and issues and problems and move them through quickly. That's our goal, is get you quickly into programs so that you can move on. We have Sunil here, a faculty member, associate professor, manufacturing and mechanical engineering technology. He's actually the graduate program director for the programs that we're going to be discussing today. We also have John here, who is the professor and the chair of the department. So we have some pretty deep knowledge here for these particular programs. And we have Lauren here. She's going to be help kind of guide us through this presentation today too. So there's a kind of a team of people here that are here to support you, get your questions answered. And there's even some more people I'm going to refer to later who aren't in this meeting today, but I will provide you their contact information to get even more admission support. So Lauren, we're going to move on into the next slide. So I think there's some alumni out there today. So you probably know kind of about Michigan Tech, but I'm guessing a few of you maybe aren't as familiar with Michigan Tech. So I'm just going to give you a couple of quick fast facts about Michigan Tech. In the state of Michigan, we're a public institution. We've been here since 1885, so we've been around for a while. We've had graduate students. We've been teaching graduate students from 1889, so that's nothing new for us. We've been in the graduate education world since the very start of our existence here. We are a public R1 research university, so that's a Carnegie classification for research activity, and that's the highest level you can get, and we're very proud to be in that group. We're HSTEM focused. So many people are familiar with the STEM side, science, technology, engineering, math. Well, we got an H on there too. We do health research. We also have a fully accredited business school here too, so which has a variety of graduate programs. Enrollment, 7,400 students. That's a total graduate, undergraduate. About 1,400 of those students are graduate students. So nice mix. We're not a huge school. We're not a small school. I always say we're rich in resources. We're to the level of over $100 million in research expenditures per year. So I think we're in a really good fit for many people where you're going to get the amount of attention. You get easier access to people, but we're still very rich in resources. Global Campus, that's the promotional arm of our online programs. We have over 40 different graduate programs. Today we're going to be focusing on the manufacturing engineering programs, but there's a lot of other programs out there. And then Michigan Tech as a whole has 5 different colleges within the university with over 140 different programs. So very diverse, but pretty much that STEM focus. And I'm going to turn it over to John.
Thanks, Jacques. As Jacques said, I'm the department chair. So what happened was in 2019, there was a previous School of Technology that things were changed administratively. So we joined the College of Engineering at that point. So I've been the chair since that point on to now, and has had the honor to develop this manufacturing engineering graduate program. So we started with a minor in manufacturing systems previous to joining the College of Engineering. So we already have always had kind of a manufacturing focus in our bachelor degree, MET, which some of you may be graduates of who are out there or familiar with if you are alumni from Michigan Tech. So the mechanical engineering technology has always been very applied or is applied program that has a manufacturing kind of a focus to it with students taking computer-aided manufacturing courses, facility design, quality, and courses like that that are required, and some are tech electives, and many become manufacturing engineers, but the degree doesn't have manufacturing in it. So that was kind of the reason for having the manufacturing systems minor, so students could have something. And that grew from that point into creating this master's and now PhD program. So the master's was developed and started in 2022. So we've been doing that for quite some time. There's coursework master students. There's online and on-campus students. We have some thesis students that have completed the program at this point. And you'll see later slides how all of that, those different formats work out. And then just this past spring, a year ago, spring 2025, we initiated the PhD program. And so the PhD just built on the master's in that if you come into the PhD, and again, you'll see more of the details later, you come in with a master's, you can basically just concentrate on your research. Now, both of these PhD and masters are available online to people who are working full time. So that's why we're putting on this webinar today. The last box in here is what I want to kind of focus on a bit, and that is that the faculty in the program are really the strength that I see. That I'm a department chair. I kind of have tried to orchestrate the process, but it's all about the faculty. And so, with the expertise that we have, with the industry experience that these faculty have, and the effort that they put into developing these quality online courses, is really what makes this what it is. We have faculty that have expertise in leadership. David Wanless, maybe some of you know Dr. Wanless from taking classes as an undergrad, but his specialty is in leadership. It's where his PhD is, and he developed and teaches a leadership course. Dr. Labiak, David Labiak, is a faculty member that has over 20 years of experience in industry before he came to us, and he is developed and teaches an Industry 4.0 class. Nick Hendrickson, some may know, he's come from being a first industry experience and then running our machine shop that we run in the school originally in the School of Technology and part of our department, and into now being a full-time faculty member, changed his roles and will be receiving a PhD. He's a PhD candidate right now and is doing research in wire additive manufacturing. So it's a robust group. Nick teaches a GD&T class, and he also teaches the Design for Additive Manufacturing course. He's gotten certifications and training above and beyond, all of his degrees in both of those areas that makes him an expert. So we can go to the next slide. So really, why choose Michigan Tech? Again, you may have an affinity for Michigan Tech as being a alumni, but I want to get into what kind of advantages of this degree are. So the reason why we initiated the PhD and the master's is there is no manufacturing degree at Michigan Tech until now. At the undergrad level, people are mechanical, people are mechanical engineering technology or chemical or any of the other engineering degrees, which all can move into a job as a manufacturing engineer. As many of you may have that title, but your degree doesn't necessarily reflect that. And maybe in your undergrad, you didn't have the opportunity to take many courses that were manufacturing related. So this is really the reason For that, it might be able to give you some legitimacy of your title as a manufacturing engineer to have that degree to go along with it. And you can do this while working, which is the big part. The things that we have to offer are one is being able to advance in your degree. The what we've gotten back from our grads is that they needed more in leadership management skills. We're going to be able to offer that with this master's degree. They also overwhelmingly said we need to know more about geometric dimensioning and tolerancing as a manufacturing engineer role. And there wasn't enough of that also in the undergrad. So this is part of this. So we've listened to our customers, we've listened to what they want, and we tried to put this program together to meet those needs. Go to the next. Uh, Also, kind of to go along with this, or to really give you a background of manufacturing engineering, what you should do if you have a moment is do an internet search for what's called the SME, which is the Society of Manufacturing Engineers, SME, four pillars. Quick, internet search will bring you to what's shown on this slide in more detail. You can take a look at it. There's actually four pillars. We just have the three and the fourth pillar shown on the slide because it's a lot to look at. But these are the two areas that really the degree is kind of rooted in. And myself, I'm an SME member. I'm part of the Education and Accreditation Committee that developed this new four pillars and revised it from the previous that was developed in 2010-ish. And so it was time. And one of the major emphases are in that the pillar three, which is manufacturing systems and operations, because as many of you know, because you're in industry, you know that there's many advancements in this area as far as the Industry 4.0 techniques go and automated systems, automated assembly, design for automation, all those types of things. So this is what we are bringing to the master's degree as the course in Industry 4.0 concepts is something that has really been needed in industry, and the course is designed around that. On the right, the fourth pillar, as far as the manufacturing competitiveness goes, things like quality, continuous improvement is part of what a manufacturing engineer does, right? Continuously trying to improve processes. So again, the management side and the processes side are courses that are part, and you'll see in the options that you have on courses you can take. So really the curriculum was modeled after what the experts in the field that had input on this SME four pillars have told us as academics. This is what an industry needs. This is what people that are working in the field of manufacturing and are need to be prepared for being successful. So to give you an idea of the research, we have, we're just starting. Like I'd said, it's basically a year in, right? We have a pretty decent numbers. We have a dozen students in the PhD. We have four or five that are on campus that are doing their PhD on campus, and the remaining are online working professionals doing their research kind of related to what they do on their job. This is an example of one of our on-campus students, actually, and you might be familiar with what this is, but wire arc additive manufacturing is what is WAM, and what that is basically using a welding unit attached to a robotic arm to develop a layer by layer metal 3D printed part. And it sounds like an easy process, but there's quite a few parameters to it to be able to produce a decent part. One of the other aspects of this is being able to do that process and actually do it efficiently and sustainably. And so what with this PhD student is actually doing in his dissertation is looking at the energy and trying to optimize that energy usage through this process. And along with our faculty member, Nick Hendrickson, who teaches the additive manufacturing degree, this is also the area that he is studying and using AI systems to try to optimize that system as well for all the parameters to actually get a quality part produced. Just to give you an example, I was in Boston just earlier this week at the SME Rapid, which is all the additive manufacturers in the world come to this conference in the convention center there. There were many new companies that are using this WAM system, and it's early adoption right now. There are some companies that are starting to do this, but it's just in those early stages. So this is where the research is still being done to improve this process. So that's an area, one of the areas that our PhD students are doing their research in. Okay, so really for you, what do manufacturers do? Is it, how is this needed? Pretty much every industry that you can think of. We put some here, but this is just a small list, right? So Michigan Automotive, I've heard that on this call, there's quite a few people that may be from Cummins in that type of area, engine design. There's always need for manufacturing engineers to improve processes to come up again, as I said earlier, the automation and assembly processes going on are really the key areas for manufacturing engineers. But that can translate over to more than automotive, right? So we have aerospace, we have electronics, medical, any kind of things that have to do with energy and renewables. The sustainability is a huge area in manufacturing right now that a lot of people are looking at. How can we do things to save more energy within our processes? And then again, some other areas as far as other consumer products, machinery building and construction. There's actually some civil engineers. We have a person from Dow Chemical right now, so it could be pretty much any different expertise. There's everything needs to be manufactured, right? Even our food and beverage kind of processes. Thank you.
Okay, good morning, everyone, and thank you, John, for this segue. So I'll now talk about the details of the various programs that we offer in the department. So I'd like to walk you through how you can actually get into one of these programs, what the various pathways look like, what you will study, and how it fits into your busy professional life, actually. So let's start with three ways that you can enter the program. So we offer three distinct entry points depending on where you are in your career, right? So the graduate certificate is the fastest option. So it takes just 9 credits, 3 courses, and you can be done in as little as 1 year part-time, actually. Can you go back to the earlier slide, please? Yes, sir. The master's degree is 30 credits beyond your bachelor's degree, and it is built for working professionals, and it's fully online. The PhD is for those who want to lead research and advance manufacturing knowledge. So it takes 60 credits beyond a bachelor's degree, or 30 credits if you already have a master's degree. So one key feature is that although they look separate here, they actually, these different pathways stack together. For example, your credits from your certificate can count towards your master's degree, and the MS credits count towards the PhD. So you're never really starting over. So that's the thing I wanted to bring out here. The fastest route is a graduation certificate, and let me show exactly what that looks like. So next slide, please. Yeah. So here, what we can do is, like, the certificate we have shown here requires 2 core courses. So this is the 9-credit graduate certificate in manufacturing engineering. So these 2 courses are organizational leadership and tolerance, GD&T, right? And then you can choose one elective. So that could be Industry 4.0 concepts, or you can choose design for additive manufacturing. And as John alluded to, both of these are very highly relevant to today's manufacturing landscape, right? So this will also earn you a credential that is going to appear on your official university transcript. So it's a real recognized academic credential and not just a professional certificate, actually. So, and again, those 9 credits will stack towards your master's if you decide to continue towards the master's. So if you decide to go even further and pursue the full MS, then you have 3 ways to complete it. So I'm going to talk about those next. So within the MS, there are 3 tracks, if you will, depending on how you learn and what your goals are. So there is a coursework only track, which is pretty straightforward. So all courses, no thesis or report is required. And this is really the best for professionals who want breadth and some flexibility, right? Then there is the report option. So this is also mostly coursework, and there could be a small project which can span 2 to 6 credits. And it is really great if you have a specific workplace problem we really want to dig deep into. Then we have the thesis option for those who want to have a deeper research experience. And typically this can cover 6 to 12 thesis credits along with your coursework. So this is really the path that leads towards a PhD if you so choose, actually. So but all 3 lead to the same MS degree. The difference is in how you spend your credits, actually, in research or in project or all coursework. And then whichever track you use, everyone is going to start with the same core curriculum as I'm going to talk about in the next slide. So all MS students complete the same 16 credit core. So there are 6 courses on the slide, and the details of these will be shared with you later in the form of a link. So the highlight, I'll just talk about some highlights. The highlights are statistical methods, tolerance analysis with GD&T, and Industry 4.0 concepts, which are particularly valued by employers. Professional engineering communication, as John mentioned, Dr. Wanless, his PhD is in that field, communication and leadership. So that is one course where students often tell us that they didn't expect to find it so useful because it really helps them in their careers. And so basically being able to write and present technical work clearly is a real career differentiator, according to them. Right. And then if you look at the list, there is industrial safety. So that really rounds out the core with a lot of regulatory and workplace knowledge that's essential in any manufacturing role. Okay. So these are some of the core courses. And once you have completed the core, you can build the rest of your degree with electives which are tailored to your careers, right? So, so in this slide, we can say after the core, you complete 14 credits of electives. So that's about 4 to 5 courses. So these span 4 areas of specialization. So these are additive manufacturing, manufacturing systems and operations, advanced materials and processes, and quality engineering. So this is where you really get to align your degree to your specific industry interests or career direction. So for example, if you work in aerospace, you might lean heavily into materials. If you are in operations, manufacturing systems electives would make the most sense. And next, in the next slide, I'm going to show you a popular elective track, right? So one popular way to use these electives is to also earn a second credential at the same time. So one popular elective path here, as shown here, is to earn a quality engineering certificate, which is really embedded within your MS degree. So you don't need to do any extra effort to gain that. So 3 courses. So these are advanced quality engineering, statistical methods, which is already in the core, by the way. So you're not taking extra coursework, and either lean manufacturing or DOE, or experimental design in engineering, right? So this is a concrete example of how you can earn 2 credentials at once. So these 2 credentials are your MS degree and plus a quality engineering certificate, right? Without adding significant extra work. And by the way, quality engineering is a high demand skill set, as we know, in many of the yeah, manufacturing sectors, practically every manufacturing sector, right? So to make this concrete, here's what a full 4-year part-time schedule would actually look like. I think many of you would be thinking about this. How does it really? How can I fit this into my career? So here we have shown you a table which maps out what a realistic 4-year part-time schedule would look like, right? So note that it is based on a fall start, right? And roughly we are making the assumption that you can take like 6 to 9 credits per year, which could be very manageable alongside your full-time work, right? And by the end of year 2, if you see the chart, you have already earned the manufacturing engineering certificate. By the end of year 3, you will also have earned the quality engineering certificate. And by year 4, you have your full MS degree, right? So again, one thing I would like to point out is that this is a sample, right? And our advisors, we are always there to help you customize how you can sequence these your courses based on the availability of courses when they are offered, and so on, and also of course your schedule, right? So here, total of 31 credits is shown here because statistical methods counts towards both the core and the QE certificate. Right. So before we move to next steps, I just want to be a little upfront about the time commitment involved. So if you can look at the next slide. So the workload is one question we often get from, it is one of the, in fact, it's one of the most common questions we get from our candidates or potential students. So for a 3 credit course, and this is the general guidance I got from talking to various faculty who teach these courses. So for a 3 credit course, plan on at least 12 hours of work per week. And that includes watching lectures, which are often posted on, which are on available on video, doing the readings which are assigned to you, completing the assignments, and also participating online. Online courses typically move quickly. So in that sense, there is not much room for catching up in a way that might be available in a semester long in-person class, right? So staying on schedule week to week is critical actually. So exam weeks and major project deadlines will of course require extra time. So you need to build those into your planning. But that said, I don't want to scare you. But the good news is that our faculty are very accessible. If you are stuck, do reach out to them and don't wait. And that's also a consistent piece of advice I often see from students who succeed in the program. Right. So if this sounds like the right fit, I would next like to walk you through what applying actually looks like.
So Jacques, we do have a
Yeah.
question. Will you stop for a second?
Yes, I think I saw you. Go ahead.
Luis Alberto Icaza wants to know if credits can transfer from other schools. If he did his MS and BS at a different school, would he be able to transfer some of those credits to this program?
So as long as the credits weren't used for a different degree, like if you used it for your degree and you can't transfer them, but if you have credits that meet the requirements of our programs, you can technically transfer in 1/3 of the non-research credits. So potentially 10 credits could be transferred over, but it's all going to be done with the approval of the actual academic program. They're going to want to see that the credits that they're transferring in are meeting the educational goals of our program and that it's a fit. So yes, possible. It's going to take a little bit of coordination and review before they can be transferred. So I think that's where I was going to take over on the next steps. And I think we can jump right into the next part of this. So some exciting news, pre-application, no GRE required, so you don't have to take the graduate records exam. That should make people happy. You do need to have an accredited bachelor's degree in an engineering field. Typically, the successful students in our programs are typically coming in with a 3.0 or higher on a 4-point scale. If you had a 2.99, we're not using hard cutoffs here. We want to talk to you, and we also want to talk to you. Maybe you're in a STEM field and you have a lot of relevant experience. So we're just giving you some general guidelines here of what we typically see for successful students. Getting into the actual requirements in the application, we're going to ask you for your educational transcripts. At this point, though, we can work with unofficial transcripts. Once you're accepted into the program and you've decided to come, we'll start a process where we'll actually be reaching out to you for your proof of degree and your official transcripts. We're going to be asking you for your updated professional resume. We're going to be looking at all the different things that you've done professionally. And that's a good place to put extra things that maybe aren't going to come out in your transcripts. So add your resume. Then we're going to ask you for a couple of statements. Personal statement, this is about you. We're going to ask you a statement of purpose also. And we give you guidelines and word counts. These aren't huge documents, but they give us a chance to learn a little bit more about you and your goals and what you hope to achieve out of this, out of the program. Then there's letters of recommendation. We have listed here one academic if possible. We also realize if you've been in your career for a little while that you maybe haven't stayed in contact with your faculty members back in your bachelor's degree, and that's okay. That's okay. That happens. If you have, fantastic. Get those academic letters. But we also will review professional letters. So like from your supervisor, team leader, like a research manager, any of these kind of people who know you well enough to say that they believe you can handle the rigors of a graduate education program and that you'll be successful. That's what we're really looking for. So those are going to be a lot of the components of the actual application. And that's what I'm here to help you with. And I'm going to introduce somebody a little bit later called Amanda Irwin. She's here to help you get through this process. Then if we have any Michigan Tech alumni in this group and you've graduated within the last 6 semesters, we have a special accelerated option where you may be able to double count some credits, but that'll be a kind of a side discussion. So if anybody fits that qualification, kind of a recent graduate within the last really 2 years, 6 semesters. So once again, no GRE, free application will help you right through there. And we have some upcoming start dates. Summer 26, possible, yes. If you're interested, I'd say once you get out of this webinar, start your application because Monday, May 4th is coming real quick. But technically possible, and we would help you if you needed to be in a program. We would help you through that application process and guide you to try to get in by Monday, May 4th. That's actually the start of classes. So probably a more realistic pathway looking at fall 2026. That would be Monday, August 31st. That would give us the summer to guide you through the application, get it reviewed. Once your acceptance comes, then there's the registration for courses and that kind of guidance. We can get you all set up to get ready for August 31st.
Hey, John.
Yes.
I just want to just let people know that for summer there are 3 courses that are being offered that are part of the certificate master's. So it would be the GD&T course, the additive manufacturing course, and the communications course. So they're all offered this summer online.
That is fantastic news because that can sometimes be a challenge what's offered in the summer, but that sounds like you have a robust selection for summer. So that's good news for anybody who is in this. So that summer thing, if it's sounding like it's a fit, let's make it happen. And we're here to help you for that. And then the spring 2027, we call it spring, but it actually starts on January 11th. But you have plenty of time for that. So you have 3 available semesters that you can start for right now available out there. So we're happy to help you. Now, I kept alluding to another person, Amanda Irwin. She works in Global Campus, and she helps students with application questions, getting through the application, getting started. I work very directly with Amanda on helping students through the admission process. Wonderful thing. She has a calendar. You have a QR code here. Set up a meeting with her. Like if you're interested after this thing, set up a meeting with her. She'll provide you with lots of guidance, give you lots of answers to even additional questions that you have to help you get started here. And like I said, I work very directly. We talk every day. So if you're looking especially to get into those classes that John just mentioned, we'll work through things to get you through the process and get you moving forward. So Amanda's another valuable resource to help you through your admission process here. And then next, we're going to jump into the application, just talk about this a little bit. There's a very helpful link here on the Global Campus site. But basically, it's kind of a 1, 2, 3 process. You create your application, name, address. I want to be a master's student in manufacturing engineering, and I want to start in summer 2026. We'll ask a couple questions. You hit submit. Next part, you're really going to get you'll get a login and a password because you're going to go into a portal. And in that portal is going to be where we're going to communicate everything. You're going to get checklists of all the things you need to do. As you do these things, you'll get checks. Once everything is completed, it'll go off to the department for a decision. And then you'll actually get your decision in this portal. We'll send you an email that, hey, there's been an update in your portal. Go and look, and that's where you get your actual admission things. So you create that portal, then you're starting to upload all those documents that we were discussing. So we try to make it as easy as possible for you to get through this process, 1, 2, 3, and go from there. So to get more information, well, you're talking to a lot of the people right now. We have Sunil, we have John, we also have Amber Thomas, who's the graduate program assistant. She can help with a lot of the questions too for you. And Amanda Irwin. So there's a whole team of people that will help you through and guide you through this process. So don't be afraid to ask. That's the whole key. It's like, we're here to help you. Our goal is to get you in the program. And then once you're in the program, we want you to succeed. We want to give you credentials. We want to see you at graduation. We all have the same goals here. So a lot of good people here to help out and some good links here for you. And then